Good afternoon, friends. Now we are discussing types of fluid flow. So, in fluid kinematics uh, of module number 2 in fluid mechanics. So, types of fluid flow. So, the fluid flow will be classified as steady flow and unsteady flow, uniform and non-uniform flow, laminar and turbulent flow, compressible and incompressible flow, rotational and irrotational flow, 1D, 2D and 3D flow. Steady flow. So it is the type of flow in which the fluid characteristics like velocity, pressure and density at a point will not change with respect to time. So mathematically we can write del V by del T at a particular space coordinate. So YO and ZO will be equal to 0. So there will be no change in the velocity. So XO, YO and ZO is the fixed point in the fluid field. Similarly, pressure with respect to time. So that is also 0. And density with respect to time, del P by del T will be equal to 0. So at a fixed point. But there is change in the time. So, but the fluid the properties, velocity, pressure and density will not change with respect to time. So, the flow will be called as steady flow. Unsteady flow is that type of flow in which the fluid characteristics at a point changes with respect to time. As the time changes, so the fluid characteristics like velocity, pressure and density also changes. So it is not equal, del V by del T is not equal to 0, del P by del T is not equal to 0, del rho by del T is not equal to 0. But in steady flow, so at different points of time, at a fixed point, so the velocity, pressure and densities, right, will be remain same. So that flow is called as steady flow. Then uniform and non-uniform flow. So here the uniform flow is the type of flow in which the velocity at any given time does not change with respect to the space. So that is in the entire length of the flow direction. So that is velocity will not be changing at any given point of time. So del V by del S, that is a velocity with respect to the space. That is the length of direction of flow. There is no change in the velocity. So non-uniform flow is the type of flow in which the velocity at any given time will change with respect to the space. So mathematically del V by del S, T is constant, that is at a particular time. So but considering the entire length of flow direction, so velocity will be keep on changing from one point to another at that particular point of time. If there is change in the velocity, then the flow will be called as non-uniform flow. Then laminar flow and turbulent flow. Laminar flow, lamina means layer. So if the flow is taking place in layers very calmly, right? So the fluid particles are moving along well-defined paths or streamlines. So that the flow will be called as streamline flow or viscous flow. Because of viscosity, there is not the flow is turbulent here. So it is flowing in the form of layers. Whereas turbulent flow is zigzag way the fluid particles are moving, so that eddies will be formed. Because of this zigzag flow, there will be a high energy loss. The energy possessed by the flowing fluid will be lost to a greater extent. So the flow, whether it is laminar or turbulent, will be decided by Reynolds number. So that is given by the ratio of rho Vd by mu. So rho is density, V is velocity, and D is the diameter of the pipe in which the fluid is flowing. Mu is dynamic viscosity of the fluid. If Reynolds number is less than 2000, the flow is called laminar. If it is greater than 2000, the flow is called turbulent. If Reynolds number lies in between 2000 and 4000, it is transition flow. Then compressible and incompressible flow. So if the fluid can be compressed, so that is the density of the fluid will be changing from one point to other point. So rho is not constant. So that flow is called as compressible flow. So if the fluid cannot be compressed, that is the density of the fluid remains same, or the fluid rho is constant, the flow is incompressible flow. Then rotational and irrotational flow. So if the fluid particles while moving on the streamlines rotate about their own axis, the flow is called as rotational flow. The fluid particles while flowing along the streamlines, if they do not rotate about their own axis, such flow will be called as irrotational flow. Then the last type of flow, so that is 1D, 2D and 3D flow. 1D flow, so it is that type of flow in which the fluid parameter, if you take for example velocity, it is a fluid parameter. It is a function of time and one space coordinate, say x. So u is the function of x. So that is, this is the velocity in the direction of x. So velocity is function of time and one space coordinate. So where the velocity components in the other two directions y and z will be taken as 0. V is 0 and W is 0. 2D flow. It is that type of flow in which the fluid parameters such as velocity is function of time and two rectangular space coordinates x and y. So u is the function of x comma y, v is the function of x comma y, and third velocity component w is 0. The flow where velocity is function of time and three mutually perpendicular directions x, y and z. So we have all the three velocity components u, v and w. Such flow will be called as three-dimensional flow. Thank you, friends.